just the system development, you can just directly generate your code. Okay, so it might be in HDL, that is hardware descriptive language code. So later on we will see that what is that exactly. Okay, later on you can deploy it directly onto your embedded processor, let's say any hardware you are specifically looking for it. Okay, so later on the, let's say the do more with Simulink. So you can do the smart editing, you can improve your models by appearance by hiding the default block names. Okay, you can also quickly group signal input and outputs to blocks and more. Okay, so next, which is the scheduling. You can mix and match export function and read based schedulable components and model startup shutdown behavior. Okay, you can see the scheduling time, then the performance. Okay, so you can get the simulation result fast using the shared model artifacts. You can quickly build your top level model and use the automatic solver option to set your models. Okay, so we just gone through these basic concepts. Now we will hold for a while. Well, nowadays the Simulink online platform also available. Okay, so earlier it was not present, so we can use Simulink online, not boxes, but this specification. Okay, so you can use Simulink through your web browser. Okay, so you can visit later on. I will show you exactly where you will get the Simulink online. So this is the Simulink interactive development environment. Let's say the Simulink IDE. Okay, instead of going through the so just some theoretical parts, we will directly switch to the Simulink IDE. Well, when you open the particular Simulink start page, you will see the different as like Simulink aerospace block set. Okay, so audio toolbox, etc. Later on, you can see the when you open one blank model of Simulink, you will see such kind of user interface. Okay, so one of the example here as like MATLAB. Okay, you yesterday we saw the live script. So in that you can insert the text, the description, the title. So similarly also you can insert here. Okay, so you can see here no programming part. Okay, here is just like a box and the connection with the links, parameters. No, well I can hear you. Okay, let me share one more time. Okay, now it is okay. Okay. We will go through the Simulink. So it will be a one interesting part of MATLAB and Simulink. Okay, so we will focus on Simulink. So when you open Simulink library browser, So first window that pop up is the library browser. Okay, so this library browser block that are available for putting into the Simulink block diagram. Wherever you click, you can take that blocks to the Simulink environment. Okay, so let's familiar with the Simulink. So let's say just joining the blocks, we need some lines. Okay, so lines block are used to generate, modify, combine, output, and display signals. Okay, so simply we can just pass the signal through that line or whatever input we, whatever interaction we do. Okay, so that goes with that particular line. That is the connection. Then the source. We used to generate the yeah, sources. Sources block that have the outputs but no more inputs. Okay, so one may want to use a constant input or let's say any sources like a sine wave, a step wave, or let's say the ramp signal, pulse generator, etc. So we need some sources. Now let's continue. Then sync discrete signals or let's say discrete blocks. Since it is used to output or display signals. Okay, so basically we will see that what is exactly. Then discrete, so discrete will filter, discrete state space, discrete transfer function, thereafter the discrete zero fold, etc. Thereafter the continuous integration. Let's go to the continuous. There it might be the integrator, it might be a state space, or let's say the transfer function. Okay, or pole zero, zero pole, etc. Then signal routing, let's say the mux, demux, multiplexer or demultiplexer, switch, etc. So we have some maths operations, let's say the absolute gain, product, slider gain, and sine, sum, etc. So we'll see. So this is the Simulink toolbar. Initially we need to do some model setting. Okay, so all the setting related to how to numerically solve the equation of the model, so it is found in model configuration parameters. Then these are the some terminology of Simulink toolbar. Let's say the run model. So you need to just for how much time you need to just give the time here, mention your time, and simulation normal other modes you can. So external stand for, let's say if you want to just use the external, I will show you. Okay, once we go to the Simulink. The later on the build models, if your model is interactive with hardware, you will need to build the model before it can run. Okay, so current status is shown in lower left of the Simulink window. Now we will directly go to the Simulink. Okay, you can directly type here in command window Simulink, or we have the option here Simulink. Okay, so screen is visible. Yeah, just give me anyone feedback. Screen is visible. Okay.
Yes, sir.
Okay. Okay. Sure. Thank you. So when you just open this Simulink, you will see this kind of environment. You will see. Okay. So Simulink, it may contain other toolboxes. Let's say audio, AutoSAR, communication toolbox. Then the popular one, DSP system toolbox, embedded coder, powertrain block set. This is also one of the pop Simscape. Over here you can see the electrical Simscape electrical three phase, hydraulic, gas, magnetic, mechanical, rotational. So many things are present here. Multi-body too. Okay. Then state flow. Okay, so parallelly with the Simulink we can use state flow too. State flow is basically to define the where the, suppose if you run any If you design any system, you can give the status of particular instance. Let's say it is running, or some operation is going on, or whether the activities is finished or not. Okay, and the rest, which is the system composer, data on the vehicle dynamics block set. Okay, so in that, this kind of passenger 3 DOF vehicle, passenger 7 DOF vehicle, then 14 DOF vehicles are present. Okay, then wireless SDL toolbox. So here it is for the let's say the SDL stand for the hardware descriptive language. So for that we will use this kind of toolboxes. Okay, so let's move. We will initially see Simulink. So when you open Simulink, you will see the blank model, blank subsystem, blank library. Okay, and the let's say the rest. This is for the blank model. Some of design, some of like for the code generation, for the creating a digital filter, then signal processing, or any simple project. Okay, so this kind of blocks are present. You can use any one. I will go with this create model. Okay, so we will see very basic instead of complex one. So as like Simulink uh, and MATLAB. Okay, so in MATLAB you need to write the script, whereas in Simulink you have to just add the blocks. So initially we will see here you can add any text block. Let's say that. Okay, okay, so in this manner you can give your title. Okay, so you can insert any image here. uh, you can use these kind of options. Okay, you can use this sample time. Then this is for the your canvas. Okay, so this is the untitled. Initially I will save this with, let's I will give is its name as a model 01, and it have the extension for Simulink. It have this extension .slx. Okay, and the .mdl. So we'll save this model. We'll see, we rename this. Okay, so we'll go with the library browser. As we saw, this is the library browser. Okay, so for every block set there is a library browser. There is option in library browser. Okay, so for Simulink, then the rest toolboxes we already gone through, like just for information, let's say the communication toolbox, computer vision toolbox, control system toolbox. Okay, so many toolboxes. Then this is ROS, robot operating robot operating system toolbox. Okay, so basically it is, this is used, we have MATLAB have its own robot operating system. Okay, you need to install it to the for using the robot operation or doing the research. So similarly, these are many toolboxes. Okay, so we'll go with the Simulink. So when you go, we'll see the commonly used blocks. Okay, let me enlarge this so we can see. They are constant, gain, subsystem, mark, switch, this kind of common blocks. Then continuous. Okay, so derivative, integrator, this kind of toolboxes. Then dashboard. Okay, so dashboard, let's say if you are designing some in system, so it need gauges, knob, or lamp, push button, slider. Okay, so very interactive toolboxes are here. Okay, so not like MATLAB script. So here is just you need to add this particular block. Then disconnect. This is logic and bit operators. So it is, you can see here bit set, bitwise operator. Okay, now lookup tables, math operators. Okay, so absolute, addition, then gain, let's say the dot product, and this is the sinks. Okay, sinks is for to display the output. This is the sources, that is the input of the input block. Then string. Okay, Now, and thereafter you can design your own, let's say, the block. So you can use user defined functions too. Okay. So then additional, we will see few additional math discrete and quick inset. Okay. So we'll start with the sources. Suppose I want one sine wave, so I will just double click here, or I will use sine wave. Okay, we'll see here. This is the sine wave. Okay, when you open this, so we'll see the block parameters of sine wave. So you can see here sine wave output a sine wave. The, let's say, the syntax for amplitude into sine, then let's say the frequency into t, that is time, plus phase plus bias. So you need to define your parameters. It might be a time based or sample based. Then using simulation time or external signal. Okay, so external signal, sometime, let's say any sensor give the input, then the simulation gets started. So let's say that we will go with simulation time. The amplitude, bias, frequency, sample time, these kind of parameters are present. Okay, we will see one by one. This is the sine wave. Now what I want, okay, so you can give this block. Suppose if you want to display this particular, just we need to go to library browser and just use sync. So we will take any output option. Okay, we'll use scope here. So basically this is the scope. Okay, so when you open this scope, you will see for the, let's say, the signal visualization, or the to see the output of particular block, we will use this scope. So just we need to just go to here. Okay, so you can use the mouse to connect this particular line. Okay, when you go to this block and just connect it to other blocks. Sine wave scope. Okay, so let's say I want to give the name this as a sine wave. Okay, so let's say the time, which is 10 seconds, then we'll set as a normal. Okay, so first example we will see, we'll just run this. Okay, we just completed the simulation. Okay, now we will see its, okay, this is the sine wave. Okay, you can change, I will add this legend here, or let's say it will be here. Okay, so we will do some configuration, when to open, when to, or let's say the configuration properties of scope. I will set open at simulation start. Okay, so when the simulation is started, it will automatically open. Okay, so how it, we will go stepwise. Okay, so in this manner we will see. Then we can measure some of the, let's say if you want to find the peak, let's say the value in between. Okay, so we'll consider one, only one cycle, or let's say the This is the one full cycle which is started from 0, then here. Okay, so we'll set it here one side. Okay, you can do the measurements, the time measurement. Okay, so for you, just calculating between some parameters, you can use this later on. Okay, so we just saw one sine wave here. Okay, so I will add one more sine wave. Okay, so you can just directly copy this block also. Okay, so you can see here simplest way. I will change the amplitude to 2, then frequency, let's say the 10. Okay, I will apply this, and what I want, two port through this scope. I will increase the number of ports and just connect the sine wave. Let's say the 2. This is the first one, sine wave first. Okay, then we will see the simulation. First sine wave, second sine wave. Okay, so initially we used library browser, but as you do the more practice, you will be familiar with directly canvas. You can just write the block name, you can call it here. Okay, so I will just double click on canvas. Okay, so we just saw. Okay, so now you can see I will add legend here. You can differentiate here the first sine wave and the second sine wave. Okay, so you can see. Okay, when you go stepwise. Okay, suppose if you want to see in these two. Okay, the first sine wave and the second sine wave. So you can use this kind of view. Okay, so let's say it is like a axis scaling, or let's say you can configure here. The layout you can change. Okay, so simple. We gone through simple blocks of sine wave and two sine wave. Okay, so now what will I do? I will just clear this. Okay, now the second example, which is okay, so integrator, one of the, let's say, example. Okay, so integrator block. So it has the some particular symbol. Okay, it represents the integration in the Laplace domain, and its output is the integral of the incoming signal. We can add an integrator block to integrate the lamp signal. Let's say a ramp signal. Okay, so initially we will see how to call a particular block. So I will just write its name, ramp. Okay, so you can see it, and the parameter, let's say the amplitude, then the slope, the start time, and initial output. Okay, so what I will do here, I will just see the, okay, instead this I will just use the integrator block. This is the integrator block, the ramp input block, the ramp signal block. Okay, so integrator you can see here. So what kind of external set you want? Okay, we are dealing with the block parameter of integrator, so you can use on the rising edge, or let's say the falling edge, or either level or level hold. Okay, now the initial condition we will set it to internal, then initial condition which is 0. Okay, so many options are present here: limit output, wrap state, show, let's say the show saturation port, etc. Okay, what I will do, I will use here scope. Okay, it will take time. Okay, so initially I will use two ports here. So initially we will see the signal. Okay, okay, you can do the branching of this particular line. Ramp signal, integrator, and let's say the scope. Okay, now I will run for, let's say, 15 seconds. Okay, now either you can go stepwise or directly you can run this. Okay, so you can see here the two signals. Okay, so the RAM signal which is this, and the integrator which is this. Okay, it will look interesting when you go stepwise. Okay, how it passes. Okay, and you can see here at the right corner the sample based. Okay, the time at particular 9 second, 9.3 second, where the signal leads. Okay, so I set to the 15 seconds, so you may see up to 15 seconds we have these visuals. Okay, if you want to change let's say initial slope or anything, you can change this. Okay, so we just saw one RAM signal, okay, with integration block. Well, if you want to just give this output to the MATLAB. Okay, right now we are dealing with the only Simulinks. So what I will do, to workspace. Okay, and that is for the MATLAB. If you want to give this output to, let's say, I will add one more port to it. Okay, so initially whatever output I will give this. Okay, now I will run this. Let me show you where the can see the simulation output here. Okay, then you can see the variables of it, simulation output. Okay, sim out, the t out, simulation metadata, error message. So you can see the time and respective data. Okay, you can see here. So directly you can export this to your MATLAB, as I told you, the data driven. Okay, with the two workspace block, you can define its parameter to its name, the decimation. So many parameter you can assign a structure with time, structure, array, time series, etc. Okay, now we will go with one example of pulse generator. Okay, so for that particular, we need to just find out or just add pulse generator here. Okay, so sequence, it is like one amplitude, then period, it is 10 seconds, pulse width, that is the percentage of period, that is 5. Okay, so I will use this, then I will use one, let's say the integrator block. Okay, so I want from here I will take it some blocks. Okay, anything we can take it as we want. Okay, so some of the, okay, so I will use here integrator second order. Okay, I don't want this, so I will just define here with a single order, sorry, double order, that is 1 by s square, integrator second order block. Okay, you can decide its initial condition, then dx by dt. Okay, then attributes. So let me minimize this. Okay, so here I will use gain. Okay, sum of the multiplying factor, so it might be 1 or 2. Just connect it to the particular block later on. Now this time I will use like this. Okay, so let's run this. Okay, you can see the data of particular, let's say, I need one more port here. Okay, so I will directly use this. Okay, so you can see integrator block output first and the second. Okay, so it is for the x, and second one which is for the dx. So now we will see some other examples. Okay, so it is like a, let's say we gone through some initial examples. Okay, then the Newton, this one of the example, Newton's law of cooling. So I will not go with the complex things. Okay, so initially you need to be familiar with the Simulink so that you can go and do the practice. Okay, initially you need to be the familiar with the Simulink environment. Okay, So in this lesson, we will model the right side expression in two parts. Let's starting with the expression t minus t0, and we can add a constant block to represent t0. Okay, so we'll see as like this. Okay, so instead this I will directly we will see one example. So we will see one algebraic equation. Okay, so here is the equation. Okay, so the equation which is y which is equals to a square minus 3a into b, okay, minus 3ab plus square root of b. Okay, so what we will do, we'll take this same parameter we will define. Okay, so here when you see this example, okay, what is the equation? A square into let's say minus 3ab plus square root of b. So initially we define some constant and variables. So let's say we'll start with the one. Instead again we will use constant block. Okay, so here we'll rename it as a. Okay, same block I want, I will rename it as a b. Now what I want, a square. Okay, so I will use square block. Okay, so first what part which is completed, a square. Now what I want, 3 into ab. So here is one, let's say the mathematical block required, that is here is the subtraction and addition. So I will use here block. We can change its sign. Okay, so icon shape I want rectangular, then list of signs. Okay, so what I want, subtraction and addition. So initially this is positive and I want to subtract. Okay, and the second which is the 3 into AB product book. So what I will do, I will use here product block, and product of let's say A and B. A and B. Okay, so 3, later on I will add one, either gain or, okay, I will use gain with factor 3. Okay, so you can see how mathematically the expression is and how we are representing that expression in Simulink. Okay, you can see here A and B multiplied. This is the product block. Okay, now this is the multiplication of 3. Okay, now what I want to add this. Okay, I want one more port. Okay, I will do little bit modification. First part which is here, second which, and the third what I want. square root. Square root. Okay, so initially we took the square of a square. Now what I want, the square root. Okay, let me do the branching of it. Okay, now the sum block. I want it as a minus, plus, and plus. I want to change the icon shape, that is rectangle. Okay, you can see here no programming part we are doing. We are just adding the blocks. Okay, so this is the addition. The second one, which is the, you can see here. Okay, I will change its order so that plus minus plus. Okay, so it will not be the confusion to us. Okay, the first, the second, and the third. Okay, you can use any display here. Okay, so suppose if you change any parameter, let's say the value of a, if you want to change it to 5, and the b value which is, let's say, 7. Okay, so this expression which is y equals to a square minus 3ab plus square root, we design here with the help of blocks, different blocks. We'll see the, we will run this, you can see the answer. Okay, you can see the answer. You can give any value, let's say 10. Okay, see the value. Then let's say if you want to change this to 2. Okay, so see the values. Okay, either you can use here let's say slider also. Okay, this is not the correct block. Okay, so either you can use slider, simple slider. I want. So minimum to maximum, that is, let's say, 50. Okay, so you can use label where top, bottom, or you want to hide, you can hide it. Okay. Okay, we just inserted one value here. Now we'll rerun this. Okay, so either you can use your slider too, or let's say any other block if you want to use, let's say. Okay, so initially also I made that example. Okay, so same signal like a and b. Okay, then it is the product of a, b into 3. Okay, so this is the summation block. and the output. Okay, let me close this algebraic equation. Now we will go with three different signals. Okay, so initially we will take sine wave. Here is no programming part, just give the block names. Let's say the transport delay. Okay, through block I will take the first one, the second one, then integrator. Okay, so then I will see the output to scope. Okay, so I will do the branching to it. One more branching to here. So very easy to run this example. Okay, so it is very easy part. You can see we took one sine wave. Okay, then we took another block of transport delay and one of the integrator block. Okay, so let's say we will define this line as a sine wave. The second one, which is the delay. Okay, I will call it as a t delay, that transport delay. Okay, and third, which is the integrator. Okay, just run it. You can see the simulation of it. Okay, so three signals. You can give the 30-second time to. Okay, so we'll see for particular 30-second how it goes, 0 to 30. Let's say for 60 seconds. Okay, so you can change the time. Now we will go with the next example. Okay, so one example which is the model x which is equal to x. So we start drawing a simple let's say simple block diagram. Okay, initially we cannot go with this. Okay, if you are familiar with canvas, you can go with the Simulink canvas, or either you can take the pen and paper and do the basic you can just you can draw the basic simple block diagram. Okay, so here x which is equal to ax and a which is equals to minus 1 by t. Okay, so t which is the time constant. Okay, now we will use the following. So let's say t which is equals to 5. Some condition is put here, that is x of 0 which is 1 and 0 less than and less than or equal to t which is less than or equal to 25. So we'll see. Okay, so what is that exact parameter we will see. So here the integrator block we used, then gay which is the minus 0.2, integrator block. Okay, so the gain block. Okay, so you can rotate it. Okay, so that goes to the scope. Just connect this block. Okay, I want stop time 10 seconds, and the gain which is minus 0.2. Okay, now we can see the simulation of it. So simulation which should look like this. Okay, we need to define the, let's say, the integrator parameters. Initial condition to 1. Integrated block, gain block, and scope. Okay, now we can see the properly simulation of it. Okay, so we'll see some logic of if else if else condition. Okay, so if else condition with this block diagram. So what we did, we just given one constant block, name it as a if, and the second which is the else. The input we decided one kind of input. Okay, so it is also one constant block. We took here as one switch block. Okay, so from here or directly from switch. Okay, so you can change the condition, and one display we took here. Okay, so threshold we set here 2.5. So it is simply a if else condition. Okay, suppose if I run this if and else case. Okay, so 2 which is greater than 2.5, so it is the false condition. If I will change the input which is greater than 2.5, so if the first case which is true, and it gives the if output. Okay, so it is one of the simple if else case example. Okay, then let's say, okay, so one thing which is remain here, subsystem. Okay, so this is the example, and initially when you go on and see that the particular blocks are present, if you don't want to just integrate this, okay, just don't want to integrate this, so you can okay, so just select this. I want this part should be in one system, so I will create one subsystem. Okay, so every block that present inside that subsystem, that is integrated with subsystem block set. Okay, you can see here, if you just go inside this, you will see the same system which is you earlier designed. Okay, so it is very helpful. You can use other component like insert subsystem, automatic subsystem, variant subsystem. Okay, reference model, many things are present here. So subsystem we just saw it. Now we will move to a few examples, then at the end I will tell you where you will get this all examples. Okay, so as like MATLAB, yesterday we gone through the MATLAB on ramp self-paced course. Okay, so today also we will see the Simulink on ramp. Okay, so if else case we already saw, then we will see the uh, let's say one more example, which is the uh, advanced example we will see with the logic operators, or let's say the bouncing ball simulation. Okay, suppose when you drop a let's say complex example. Right now I go on with the simple examples. Okay, now we will go with the advanced example. So mm, okay, so this example, which is the data type example. Okay, so initially this is the one of the sine wave. Okay, so amplitude which is 150, the frequency which is 1, and sample time which is 0.01. Okay, it is converted to the integer 8, then convert on the second block, which is the which which is of the unsigned integer 8. Okay, it is the signed and which is the unsigned. Okay, then here the relational operator which is used. Okay, then here is the data conversion, that is to fixed point to other fixed point. Okay, so when you see that particular block, so output minimum, output maximum, then output data type fixed dt, then integer rounding mode, that is 0. Okay, when we run this example, okay, so see the first. Okay, then see the data type double, then integer, then unsigned integer 8, then boolean. Okay, so we are not able to differentiate over this. So what we do, we will use different axis. Okay, so we need 4 axis. Okay, you can see the particular simulations. Now we'll move to the complex example. Okay, one of the example of signal processing, data type filtering example. Okay, it is one of the signal waveform. Okay, so which is the sine waveform with amplitude 100 and frequency which is 1 hertz. Okay, you can see the block parameter too. Then we added some additive noise. Okay, this is the zero order hold. Then signal scaling, one let's say the subsystem. Okay, when you go subsystem, we'll see other, just minimize this system. Then reduce precision, other blocks are also present here. When we just directly run this, okay, so this is the output, reduced precision, the error. Okay, so no error is present, the signal which is at 0, the full precision. Okay, so this is one very interesting example using Simulink. Okay, so this is basically one bouncing ball model. So when you just throw one bouncing ball, how it goes? Okay, something went wrong. Let me see. Actually, it will show some pattern. Okay, it have some. Okay, I will take one more. Okay, so one complex example. Okay, it is very complex example. Okay, so Foucault pendulum model with VRML visualization. Okay, so basically this model solve the differential equation for Foucault pendulum problem and display the pendulum bob movement in the VRML scene. Okay, suppose I will run this. Okay, so you can see here. Okay, so basically this is okay, very complex example. We already did the simple Simulink example. So this is all we design in Simulink. Okay, and this is the point where we are pointing. We are pointing. Okay, so few parameter we will see. Okay, when I will stop this. Okay, so let's see. So many systems are used here. Earth rotation speed. Okay, when you go here, the earth rotation, then perspective, longitude and latitude. Okay, and the pendulum scene. Okay, so integratedly you can see many things here. So it is one of the complex example. Okay, even we have considered some top. This is top view, the front. side view. Okay, so many complex example you can design with Simulink. You need a lot of practice over this. So other useful blocks is like bus to vector, data type conversion. Okay, so Simulink on. Okay, so as I told you today, to complete MATLAB RAM. So similarly you can use Simulink on RAM too. Okay, so it will create your most of the routes. Okay, so the most of the content whatever I discussed, that is I delivered. Now let's move to Q&A session. Okay, so as I told you, this is Simulink on ramp. Okay, we'll see this. Okay, so you can see the environment of online, let's say Simulink online. Okay, so you can use Simulink. That's the web based, that is browser based on browser based platform. So you can just, we will see the overview of this course. Here you will find Simulink on RAM. Okay, so most of the uh, agenda we discussed, that is delivered. Yeah, please go with Anup sir. We will go with the Q&A session. Very simple example I covered here. Okay, not for the complexity. Yes. Okay. 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 I will provide one link in chat section. Okay. This is for the practice session. Okay, just go through it. You will find it is very helpful to you. Okay.
Sir, it works in 2018 a MATLAB also, na?
Sorry, I can't hear you
Sir,
properly.
uh, MATLAB, MATLAB previous versions,
Okay.
they also work. Uh,
Yeah, yeah, it is integrated with the, let's say if you wrote any program in earlier version that support the newer version, even it will run faster in newer version. Okay.
okay.
Yes, sir. Yes, sir. Yes, sir. No. Uh, No, let me tell you that the MATLAB and the Simulink, which is the desktop version, and the MATLAB and Simulink, that is the online browser-based version. So browser-based version, it is the customized one. So for complex programming, we will not going to use the browser-based. Okay, for the simple programming, or let's say designing simple system, we can use browser-based platform. Otherwise, we have to use the desktop-based platform. Okay, okay. So I think no question is there. Okay, so shall we end this session? Okay, okay.
All the participants are requested to start the camera. सर कुठल्याही ग्रुपमध्ये आहे ना आपल्या टीमची लिंक आहे ना. केलेच सगळं टीम बऱ्यापैकी सर. The link for feedback is shared in the chat box. All participants are requested to submit the feedback.
Okay, thank you, sir. Thank you. Thanks for giving me the opportunity. Okay, I will leave the session. Thank you.